The On-Farm Network investigated foliar fungicide applications with interested farmers from 2014 to 2020 in soybeans specifically. We'll review results from those trials today. Before getting into them, though, I'd like to provide some background on different soybean diseases that are infecting our crops in Manitoba. Annually, MPSG agronomists, Manitoba agriculture agronomists, and Ag Canada staff survey soybean fields for diseases during August. Common diseases we see in soybeans are bacterial blight, septoria brown spot, downy mildew, frog eye leaf spot, white mold, fusarium and phytophthora root rots, and northern stem canker. Of these disease symptoms, these fungal diseases highlighted in orange, those are the ones that are controlled or suppressed by a foliar fungicide application. Taking a closer look at some of those foliar diseases in a bit more detail, for bacterial blight and septoria brown spot, both are leaf lesions. Bacterial blight lesions are brown and typically surrounded by a yellow halo, and they're typically found in the mid to upper canopy, since it's setting in following leaf damage from winds or storms, so it's usually the tops of plants that are affected. Septoria brown spot, on the other hand, it's a fungal disease that's moving up from the soil. So it's found more often in the lower canopy at the base of the plant, and they're starting just as these little brown speckles, and there's no yellow halo with septoria. So both of these lesions are usually small and pretty unconcerning, but you will see them every year, so I wanted to make sure you were familiar with them. Two other foliar diseases up close are downy mildew and frog eye leaf spot. With downy mildew, the upper surface of the leaf will be a pale green color, and if it's humid on the underside of the leaf when you flip it over, you might find a fuzzy gray mold-like growth. For frog eye leaf spot, we have these small irregular or circular spots on the leaf. They're tan in the center, and the edges of the lesion are dark purple or a reddish brown color. For white mold symptoms in soybeans, during potting, you'll find these wilted plants in the field, and when you open up the crop canopy to take a closer look, those stems will be bleached rather than healthy green in color. And if it's been humid, there might be some of this fluffy white mycelial growth from white mold. If it's more dry, you might just find these small white bumps on the stem. In both cases, though, if you break open those stems, you'll often be able to find these hard black sclerotia bodies, and that's how white mold is overwintering. And then for northern stem canker, to be aware of that one, this disease starts as these small reddish brown lesions on the stem, and then as they expand across the plant, they form these kind of larger sunken cankers, and it can infect most of the plant. It can also look a lot like Phytophthora because plants might wilt, but when you try and pull those plants out of the ground, the roots are still healthy, and that's one of the clues that it's something else. With all of these diseases, though, if you are ever curious and want to get a disease ID, Manitoba Agriculture does have the Crop Diagnostic Lab in Winnipeg, where you can send plant samples to for free, and they will let you know what diseases are infecting your crop. It's a really great tool. How common are each of these diseases, though, in our soybean fields? Over the last 3 years, on average, we're finding bacterial blight and septoria brown spot in most soybean fields. Downy mildew has been found in 13% of fields on average, and frog eye and white mold have infected about 4% of fields on average. Root rots I won't get into too much today, but we do find some level of fusarium root rot in every soybean field every year. Phytophthora root rot has been less common, infecting about 4% of fields on average, and then northern stem canker has been infecting 14% of soybean fields on average over the last 3 years. Within those infected fields, the impact of these different diseases on yield comes down to how many plants are infected in the field and how severe that infection is. So we do find a lot of plants infected with bacterial blight and septoria brown spot within the field, but it's often at trace levels, which means that it's the odd leaf that's infected on a plant. Downy mildew, frog eye leaf spot, and white mold have also been quite low on average within the field. Fusarium root rot severity in the last 3 years has averaged 4.5 on a scale of 0 to 9, meaning there's a lot of fields where yield is actually impacted by this root rot. And for Phytophthora and northern stem canker, I don't have the data for their infection levels within the field that they were found yet. But today we are talking about foliar fungicides, which means we're targeting these fungal diseases highlighted in orange. Of those diseases, white mold has the greatest potential to negatively impact soybean yield. White mold has a pretty broad host range, infecting the majority of our broadleaf crops. Soybeans, in comparison to other broadleaves, generally don't see as severe infections of this disease very commonly in Manitoba. Their more upright growth habits allow for a bit more airflow than something like a dry bean or a canola crop. And this airflow definitely helps limit mold spread within the crop. However, in those occasions where white mold is more prominent or present in a field, it can be pretty damaging. So for every 10% increase in the amount of plants infected in a field, anywhere from 2 to 5 bushels per acre of yield are lost. Early infections are definitely more damaging. We're fortunate that it's not as often that we're seeing high levels of this disease in our fields. With that introduction on soybean diseases, let's talk about on-farm trial results. The goal of these trials have been to assess the agronomic and economic impacts of a single foliar fungicide application versus none in soybeans. So will that fungicide application reduce disease pressure, and will it protect yield and provide a return on investment in Manitoba? From 2014 to 2020, there have been 66 trials comparing a single application of fungicide applied at flowering versus none. So product choice has been up to the farmer, and they're all applied according to label recommendations. Some background information on these trials so far. Average application date was about July 11th, though app date range was anywhere from July 1st to July 21st. Average plant stands in these trials were about 147,000 plants per acre, and it was a fairly even split if these trials were on narrow rows or on wider row spacings. Products applied have included Acapella, Categra, Delero, Diax, and Priaxor, and the number of each trials of each different product are in this table on the right. So previous crop can play a role in disease carryover with white mold and other diseases. So here's the distribution of previous crop for these trials. Most of these soybean trials are going into wheat stubble, either winter or spring wheat. And then soybeans on soybeans is also another pretty common previous crop. Second most common out of these trials, which isn't great to see, but it's worth knowing, especially when you're investigating disease. July rainfall and the moisture around flowering can play a role in disease development. So this is the percent of normal July rainfall for each individual trial. The orange line across this bar is 100% of normal rainfall. So at 23 trials, we had normal or greater than normal moisture in July, and that's about 42% of trials were wetter or as wet as normal. And then in these trials, we rate incidence or the percent of plants infected and severity of white mold, septoria brown spot, frog eye leaf spot, and downy mildew. Bacterial blight and Phytophthora root rot are also noted, but they're not controlled by a foliar fungicide application, so they're not really the ones we're paying the most attention to in these trials. White mold was present in only 3 of the 7 years of these trials, so in 2015, 16, and 17. And white mold was only present in about 1/5 of the fungicide trials. So white mold ratings and incidence for those 3 years where the disease was present are in these graphs along the bottom. The rating scales did change between the years, so that's why there's kind of 2 different graphs shown between 2015, 2016, and then 2017. And the stars within these are indicating the trials where white mold was significantly reduced with that fungicide application. And white mold incidence was significantly reduced with that fungicide app at 6 trials, which is 9% of the time overall, but 43% of the time when white mold was actually present in the trials. So if white mold was present, 43% of the time it was reduced with this fungicide app. But what did that mean for yield results in these trials? A single foliar fungicide application improved soybean yield 15% of the time, on average improving yield by 1.3 bushels per acre. The trials that were significant are highlighted in green here. So they occurred in 2015, 2017, and 2018. The number above the bars, that's the yield difference between an application of fungicide and none. How much was yield improved at those trials? And when we're looking at these responsive trial sites, what did they have in common is the question we're asking. Can we predict where we might see a yield response to soybean fungicide? So at these 3 trials here, we also saw a reduction in white mold disease pressure. These yield increases over 2 bushels per acre were because the fungicide was protecting the crop from white mold at those sites. So 2 of these 3 trials with more white mold were also where soybeans were being grown on soybean stubble. So that rotational risk is showing up a little bit here. But at these 8 other responsive sites, white mold wasn't present in the trial. Something else was contributing to this yield response. Another disease to look at was Septoria brown spot. It's also controlled by the fungicide application. Incidence of Septoria was reduced at 5 trials with an application of fungicide, but the severity of Septoria in those fields was so low that it's really unlikely that that would have actually caused these changes in yield alone. So in summary, a single application of fungicide did improve soybean yield 15% of the time. The larger yield responses were because the fungicide application was protecting soybean yield from white mold. When conditions are ideal for white mold to develop, soybeans can benefit from a fungicide application. But over 7 years of data in 66 soybean fields, it's not very frequent that we're seeing this yield response to fungicide in soybeans in Manitoba. To assess the risk of white mold developing in your soybean fields, there are some factors we can consider. It starts off with the weather around flowering, both the weeks leading up to it and the conditions while the flowers are open. Warm, humid conditions are preferred for white mold development, with optimal temperatures pretty much being your average summer day, and rainfall being typically more key piece. If we're seeing 1 to 2 inches of rain within 1 to 2 weeks of flowering, and that persistent leaf wetness when walking through the crop, risk is going to be higher for white mold development. Thicker, denser canopies will also create a microclimate that is more humid and cooler, promoting disease development. And the last risk factor to consider is your cropping history. If there are several host crops in rotation back to back, risk is going to be higher. So if you think of that last canola, bean, or pea crop in that field, what was disease pressure like then? If it was high, there's bound to be some more carryover of that white mold sclerotia in the field. The last few dry years, that answer to that question might just be you're at a low risk, but we have had more moisture this year and more white mold. So keeping records and keeping that in mind for your future crops in those fields will be important. Because if all these risks are co-aligning, it is worth considering a foliar fungicide application to protect yield. Other management strategies are, of course, crop rotation, rotating away to cereals or less susceptible broadleaf like flax. Wider rows and lower plant populations will improve airflow throughout the crop canopy, but ultimately that's also going to reduce your overall yield potential. So foliar fungicides are a tool we can use, and for white mold, they're preventative, meaning we need to assess that risk ahead of spraying. But these trial results are really showing us that that foliar fungicide response isn't as often. It's only 15% of the time that it's really improving soybean yield. So if you're interested in learning more about these trials and these results, every trial result is available in the On-Farm Network database at manitobapulse.ca or by following this QR code. If you are interested in participating in a trial, contact Ian. He's our On-Farm Network technical specialist. His contact information is on the screen here. Thanks for your time today. I've been Laura, MPSG's Western agronomist. To stay up to date with research results like these, follow us on social media by finding us on these different spots. Thanks.